Hi guys, today we are going to discuss the problem merge intervals which was asked in Google interview. So what this problem states that we have given a set of non-overlapping intervals in a sorted order and we have to add another interval in this list in sorted order which must be non-overlapping. So let's discuss this example to understand this problem better. And in this example, we have given 5 set of non-overlapping and sorted interval. And we have to insert this new interval into this list. Before adding new interval to the list, we first have to remove all the overlapping intervals. So all the intervals that are going to overlap with this interval are not going to be the part of the answer. Only the remaining intervals with this interval in the sorted order will be the answer. Okay, so let's write the code for this problem. So in this problem, what we are going to do is we are going to take all these intervals and put this into a map. So let's do this. I will take a map of int comma int and name it m and insert all the array elements or intervals into this map. So map dot insert make pair. Now the values that we have to insert is a of I dot first comma a of I dot second. So first and second are the value of pair, left and right value. So till now we have created this map, and now we see the left and right value of new interval, which is 4 and 9. We store this in a variable, so int left is equal to new interval dot first and int right is equal to new interval dot second. Okay, so now we can just add 4 comma 9. So to add, we will just write map of left is equal to right. So before doing anything, let's just run this code. So for auto I in m cout I dot first I dot second. Okay, so make merge intervals. Okay, so here we can see that 1 2 3 5 4 9 6 7 8 10 10. So all these intervals are printed, but we see that 4 comma 9 is inserted at the right place, but this interval 3 comma 5 and 4 comma 9 are overlapping, and 4 comma 9 is also overlapping with 6 comma 7 and 8 comma 10. So we have to do some deletion in this case when there is overlap. Now we have to find the starting and ending position or the reference of the intervals that we have to delete. So to get that, what we'll do is we will do a lower bound on the left side of this intervals. So this can be done by binary search in log time by a predefined function called lower bound. So we will do auto delete from is equal to map dot lower bound of left. So this will basically just give us the reference of the interval that whose left value is just greater than or equal to the left value. Similarly, we have to find the delete up to reference. So this is the value up to which we have to delete all the intervals. So map dot upper bound of right. So this code is fine for non-overlapping intervals, but in case 4 and 9 there is overlapping on both the left and right side. If we see this example, because 9 is between 8 and 10 and 4 is between 3 and 5. So let's deal with them one by one. So for left overlapping and for right overlapping. Okay, so for left overlapping, what we are going to do is, we see that this is the upper bound, but the previous interval of the delete from interval. So this is the delete from reference and this is delete up to reference. And to access the previous of delete from, we write previous of delete from. So this is now pointing to 3 comma 5, and if we do the second of this, then it is just pointing the second portion, which is 5. So now we have to check if this 4 is smaller than equal to 5. So if 4 comes before 5, then we know that there is an overlapping. So this 4 is the left side of new interval, and this is the interval already present. So if 4 comes on the left side of this 5, then this will merge with this interval. So we have to delete this as well. So this reference will be removed from here to here. So we will just uh, check that if left is smaller than equal to this value, which is 5, if or 4 is smaller than equal to 5, then we will just move the reference pointer to one above, which is delete from minus minus, and the left is right now 4, but the minimum value will be left side of this interval, which is 3. So left is equal to delete from first. Okay, so we have handled the left overlapping case, and what we have done is just access the, we have to delete this node and make the left value as 3 instead of 4. Okay, so now for the right part, this is the delete up to reference and also the upper bound of 9. So we check if the previous of delete up to reference interval, which can be again written by previous of delete up to. So this is now pointing to 8 comma 10, and if we write second, then it is now just pointing to 10. So we have to check that what is the maximum value of right, which is 9, or this value, which is 10, because the right boundary we require is the maximum uh, that is of this previous interval. So what we do is, we have to find the maximum of right and this and store it in right. So we have taken care of right overlapping also. And okay, so let's just revise one thing. We inserted all the intervals in map, and left and right is the new interval. We access the delete from and delete up to reference of the interval by lower bound, and lower bound is the value just greater than or equal to this left and right value. and this is done only on the left side of this map. So and then after that we check if there is left overlapping. If there is an overlapping, then we decrease the iterator and set the left as the minimum, and if similarly we set the right as maximum, and after that we delete all the uh, middle intervals and set the new interval and just print it. So let's run this. Okay. Okay, so this is our required answer: 1, 2, 3, 10, and 12, 16. Once again, just look at the code. This is code. Okay, thank you.